Okay, today we're going to talk about linear inequalities. So let's start with this file. I kind of like this. So this is the function y is less than x plus 3 there. So you can see that the y-intercept is 3. It's less than, so it's a dotted line, and it's shaded below that region. And this one is y less than negative x minus 1. That's this line right here. It looks to have a y-intercept of negative 1, slope of negative 1, and it is shaded above or greater than that line. And so if I shade below this line and shade above this line, can you see this kind of dark area here? Anywhere I move this point is a solution for any problem over here. And you can see that easily by plugging in the values, right? So if x is 5 and y is 2 here, so if we plug in that, let's see, y would be 2 is less than 5 plus 3. 2 is less than 8, that's true. 2 is greater than negative 5 minus 1. 2 is greater than negative 6. So both of these statements are true when you plug in this point. So I can plug that point in, and you can see that anywhere in this double shaded region is the solution region. We call that the feasible region. Notice if I put it over here, now one of the statements is true. If I plug in negative 2, 5, this statement is true, right? 5 is bigger than negative or positive 2 minus 1. That's true. But if I plug it over here, I get 5 is smaller than negative 2 plus 3. That's actually 5 is smaller than 1. That's not true. That's a false statement. So this is not a solution point. Same thing over here. One statement's true, the other one's not. If I put it over here, you can see that both statements are definitely false. And I want to do something interesting. I want to put it on the line. So maybe I'm on the line for the shaded region. Notice it's still only true for one of the statements. I think if I plug in 4, 1 here, so that would be 4 is less than 1 plus 4. 4 is actually not less than 4, it's equal to 4, so that first statement is technically false. So you have to have both, so we're inside of the shade region here, so you really have to have both statements be true to be a solution. That's the idea of what we're doing today. We're going to shade this double shaded region, the solution region, the feasible region, and that represents a whole lot of different points. I only put integer points here, but actually any of these decimal values, 4.1, negative 2, etc., would all be solutions. Okay, so let's start by graphing one. So let's start with this one here, and so we're going to graph this one in blue. So I'm going to graph the line first. So to graph this, I would plot the y-intercept, maybe of negative 1. The slope is 1. We've graphed a lot of lines like that, so I'm going to go up 1 over 1. So that's just a linear line here. I'm making a lot of slope points, so I can draw this without a straight edge. Looks something like that. And I'm going to shade, in this case, above. So this shading is going to be greater than or above that line. So really anything up here, just kind of loosely shaded, that any of that is the single shaded region here, but it's not the solution yet. So let's do the other part here and see what happens. So when I graph this one in red, the y-intercept is 2. The slope is negative 1/2. I could go up 1 over 2 to the left or down 1 over 2 to the right. And be careful here, I didn't mention this in the first one, but this symbol here is a less than right there. So right here I'm talking about this symbol is less than. So this is going to be a dotted line. So when I draw this, I'm going to do my best to kind of dot this line. This is not a solid line because of the inequality sign. And then I'm going to shade below this line. So everything below the red line here, so everything here is shaded. Can you tell where the double shaded region is, right? So the double shaded region looks to be where the yellow and green kind of overlap. Like all of this area is like the double shaded region. So that's the solution region, right? So anything in there with your, it's easier to do this with your pencil than it is a smartboard, but you're going to double shade that. Make sure that I can see that. Or some students actually do this. They'll actually like take their eraser and erase the shading over on this side. And then they'll erase the shading over on this part as well. And that's acceptable as well. Like that's okay to do and say, okay, then I can clearly see the double shading is only in this region. This is the solution region, whereas these, only one equation is true, not both. try another one. So first step, you want to be able to solve these for y. So maybe subtract the x. So 3y is less than negative x plus 6. Divide by 3, divide each term by 3. You get y is less than negative 1/3 x plus 2. So I'm going to graph that in blue here. So y-intercept of 2, slope is up 1 over 3, up 1 over 3, and down 1 over 3 the other way. And that's less than, so not equal to, so I'm going to do a dotted line as best I can. Okay. And I'm going to shade that one below here, so it's going to be, below that line. So I'm shading kind of everything roughly below that line. Let's do this one in red. Actually, let's solve it first. So if you solve it, you get negative y is less than negative x plus 2. If I divide by negative 1, don't forget to switch the sign. Right, so I get y greater than positive x, or 1x, minus 2. So I'm going to graph that one in red. So that's going to be negative 2 is the y-intercept. Let me try to push that down just a little bit. Negative 2 is the y-intercept. The slope is 1, so I'm going to go up 1 over 1. Looks like this. Looks like it crosses right about there. And this is a dotted line as well, so I'm making a dot that line. And in this one, I am shading, let's see. I'm going to shade above this line, so I'm shading above this one. So I'm kind of like all this is shaded, right, all that above. But the double shaded region is really just like in here. Oops, sorry about that. So the double shaded region is all in here, below the blue line, but above the red line there. And so all in there. Let's try another one. So this one should be easier in theory. So it's already solved for y. That's nice. So a solid line at 3. So it's a horizontal line. I'm going to shade below. Sometimes when you get better at this, you can think, okay, I'm going to shade below that line. Let me just wait on that for a minute. This one's going to be absolute value. We've done a lot of that recently. So it shifts to the right 2 units. So it looks like about this. This is a dotted line. So I'm going to plot this. Plot my slope points for the absolute value and make this a dotted line. It's not a very good dotted line, but you do the best you can. And so I'm shading above, so inside the absolute value, like above there, and then I'm shading below the y equals 3 line, so there. So if I combine the two of those, the double shaded region is below the blue line because of that symbol and above the red line, so the red graph. So it's just that area right there is the solution region. Anything in there is a solution. I think you're getting this. I want to make sure you know how to type this in your calculator. So there is a way to check your work on your calculator. So let's try to type this in to our calculator. So let me get this so I can type it in here. So let's go to a new graph page. So hit the home key and go to your graph page. Type in y is less than. So how do you type in y less than? So if you hit delete here, you can choose the second choice is y less than. That's like a relation now. So control divide 1/3. Oops. X plus 1. And go and graph that. That's nice. It graphs inequalities. Hit tab. Opens up the entry line again. And go ahead and type in y greater than. To type in greater than, if you see right above equals here, control equals should give me the greater than symbol. There it is. 2 times the absolute value. If you hit the key next to number 9 here, right here, the template key, I think there's absolute value right there. times x minus 1, and press enter and graph that one. So kind of getting out of the way here. So hopefully you can kind of see the solution region here. It looks to be right in there, kind of like a little triangle right there, where the two regions intersect. Lots of dotted lines for those, by the way. If you're having trouble seeing that, I can always zoom in. Let me just try that. Let me zoom in just a little bit. And I'm going to make that the center. So I kind of zoomed in a little. I don't love the units there. I'm going to change that to 1. Change that to 1 for the x and y. That makes more sense. This is a really nice image. So the purplish kind of maroon region there is your solution region. If you want to find those exact points of intersection, so you can do that, you can hit the menu key. There's a couple ways of doing this. I really like using geometry, points and lines, and going to intersection points. And just click the first graph, click the second graph, and it should find both of those intersection points at the same time. So there's one of them there on the right, and here's the other one on the left. And so you can see exactly where those graphs intersect. And the other point, obviously, is at 0, 0, it looks like. It crosses right down there. And so this is a nice way to check your work. And on a standardized test, if they allow you to use a calculator, you can graph it on your calculator as well. Let's try a tougher one here. So this is kind of getting into our next lesson, but I think this would be helpful to see. So let's graph this one here and see what this looks like. So this looks like a y-intercept of 4, 1, 2, 3, 4 right there. Slope of -3/2, so I'm going to go down 3 over 2 to the right. Down 3, 2 to the right. Can make my point. Let's see, dotted line, so that's dotted. Something like that, roughly. That's going to be shaded down. I'll get that in just a second. There's a line here at x greater than or equal to 0. So that's a vertical line right here. That's a solid line right there on the y-axis. I'm going to shade to the right in just a second. It says greater than. And this is a line on the x-axis. So it looks like this. And this is very common. With these two, usually you're basically saying it's in the first quadrant. You remember quadrants, like this is actually quadrant number 1. Typically your graph's going to be in the first quadrant. And so it's saying, hey, the x value is positive, the y value is positive. It's in the first quadrant. And this graph is saying, hey, let's make sure you're below this line, but inside the first quadrant, because both of these are also true. So really your solution region, your feasible region, is, I'm going a little bit outside of it there, but something like this. It's that triangle right there that forms that feasible region. And that's, I'm not sure if your lesson will get all the way to there. That's where we're headed. We're going to put together 2 or 3 inequalities at a time and find out where all 3 graphs overlap, intersect. That's the end of the lesson.